Students, today we're going to be doing two activities. Yes, two for the price of one. Two activities. And we're going to begin today with the classroom activity entitled Infiltration. Yes, infiltration. So if you're unable to be in the lab today for whatever reason, you'll be watching this online. And so you'll be able to gather your data just as well as anybody who is in school today. So infiltration, the problem of this particular activity reads as follows. What is the relationship between particle size and infiltration time? What does that mean? Well, I'll tell you briefly what it means. What it means is soil is made out of a lot of different particles. In fact, later on, we're going to be learning about soil and all of the different soil particle sizes. For now, we're going to be exploring 4 different examples of dirt. We're going to start with clay. Clay is the finest little particles. Sand is the next, a little bit larger than clay. And then gravel. Gravel is the largest size particles. And then open space altogether. So we actually have 4 different scenarios in this activity. Clay, sand, gravel, and air. And what we're going to be doing is trying to see if there is a relationship between the size of particle and how quickly infiltration takes place. So you can look at your sheet in your book with the procedures and the observations, and we're not actually even going to be recording times here as far as seconds and minutes are concerned. It's just going to be relative times, fast or slow, and more specifically, the choices you're going to have include the words fast, medium, slow, and never. And once you gather that information, you're going to create a chart, a graph, a line graph to be precise, where you're going to plot the relative time it takes for water to dribble through or infiltrate and the size of the substance itself, clay, sand, gravel, and air. So what we're going to do right now is I'm going to switch over to our lab view, and we're going to watch. And I want you to just keep words in mind, fast, medium, slow, or never. So here we go. Let's go over to the lab view, and I have it set up here already. This first funnel has nothing in it, just air. And it's emptying into a beaker here. The next one is filled with gravel. This one is filled with sand. And this one is filled with colored clay. Behind each, I have a beaker of 50 milliliters of water. And what I'm going to do is take the water, pour it into the funnel, and I'd like you to try to watch how quickly or slowly the water comes through the funnel in the bottom. And then you can record your observations, fast, medium, slow, or never. So here we go. We're going to begin with, and make sure you record this in the correct order in your book. I'm going to do it in the order I have here, so I'm going to begin with just the air. By the way, I would suggest watch all 4 of them before you write down any words. Are you ready? And if you need to, you can rewind the video and watch again. Remember your choices, fast, medium, slow, or never. First one is air. Watch closely as I pour it in. Did you see it pouring in and coming right out the bottom? All right, next one is gravel. Let's watch the gravel. Here we go. See it dribbling it out. Still dribbling, still dribbling, still dribbling, still dribbling. And it's almost done dribbling. It's slowing down. So I'll move on to the next one. Okay? The next one is sand. So let's pour it through the sand and see what happens. It took a little bit longer to start dribbling. And dribbling. And dribbling. And it's still dribbling. And dribbling. Gravel is long since done now, but the sand, still dribbling. And dribbling. And while that one is still dribbling, I'll pour it into the clay. And we'll wait. And we'll wait. And we'll wait. Nothing is coming out from the clay. So I don't know about you, but I would say this was fast, medium, slow, and never. That would be my observation, but you observe it as you wish. Now, let me go back to just me here, so hopefully you were able to get the observations for that particular activity, the classroom activity on infiltration. And what you're going to do then with your data is you're going to create a line graph plotting those two pieces of information, plotting the dots, constructing a line, and trying to come to a conclusion as to whether or not you think there is or is not a relationship between particle size and the rate of infiltration. Once you've done that and you've written your conclusion, then you can go to the next activity, which is our lab activity. This is kind of fun. And the problem of this lab activity reads, what percentage of the air we breathe contains oxygen? What percentage of the air we breathe contains oxygen? So come up with a hypothesis that percentage is. And while you're doing that, I'm going to go over to the lab view and set things up for the lab activity. So I'm going to move all of these items out of the way. Okay, here we go. Now, hopefully you have completed a hypothesis, and what we're going to do now is this little experiment to determine how much of the air you breathe contains oxygen. So I have a little pan here with a candle in it, and in a moment I'm going to light the candle. It's filled with water around the candle, and I have a test tube, an empty test tube. I have a lighter here, a marker, and a ruler. And we're going to have to take some measurements as we go through here, and you're also going to be answering some questions. Starting with, what is in the test tube before you place it over the candle? Think about what is in your test tube. And I'll give you a hint. It's the same as what we're breathing right now. Next question is, what is required to support the combustion of a candle? So I'm going to light our candle here, and you've seen candles lit before, every time you have a birthday probably, and not all of the air is required to ignite that candle, only one part of it. That one part of it, as you can probably imagine, is the oxygen. Now, what happens to the oxygen in the test tube when the candle is burning? In a moment, I'm going to put the test tube over the candle, and we're going to find out what happens. Now, before we do, I'm going to write down some numbers here, and Well, you know what, we can do that afterwards. I am going to mark something that happens after I put the test tube over the candle. So here we go. What do you think is going to happen to the oxygen in the test tube when I put the candle over it? Let's find out. Wow, I hope you were able to see that. Probably don't have the best angle there. However, if you noticed, the candle went out and the water got sucked up into the test tube. Think about why did the water level change in the test tube. And I'm going to put a little mark here because I'm going to be measuring the height that the water went up in a moment. So here I have a little red mark on the test tube, and I'm going to make some measurements here. Now think about why the water level went up. I'll explain it to you. The candle was only burning oxygen. When the candle was burning inside the test tube, only the oxygen was being burned, not the other gases in the atmosphere, not the nitrogen, not the carbon dioxide, only the oxygen. So the candle only consumed the oxygen. And so we can use this little demonstration to show or illustrate how much oxygen is in the air. So I'm going to make some measurements here, and I'll show you what we're going to do. Now, I'm going to measure this myself, and let me just head back to this view here. I have my test tube, which is now empty and dry, and I have a ruler. And I am measuring the height of the entire test tube, which I'd like you to write down is 15 centimeters. The entire test tube is 15 centimeters tall. 15 centimeters is the total length of the test tube. Now, the height that the water went up is exactly the same height as the amount of oxygen in the test tube. And I'm measuring it to be 3 centimeters. 3 centimeters. So, the height of the water was 3 centimeters, and the total length of the test tube was 15 centimeters. What I'd like you to do is this. Do the math. There's a little calculation there I've written for you in your notes. The percentage of oxygen in the air is equal to the height of the water, 3, divided by the total height, 15. 3 divided by 15. Multiply that by 100, and that will equal the percentage of oxygen in the air. Now, my little demonstration, I used one size test tube. You might be using a different size test tube if you're doing this in the lab, but our results should be pretty close to the same. So take some time, do those calculations, see what you come up with, and see how close you are to the actual answer. Hopefully, you get pretty close. And then you can write your conclusion. By the way, I'm going to tell you now what the actual answer is and what my answer was. My answer with the test tube was 20%. The actual answer, 21%. Pretty close with a silly little test tube and a birthday candle. Let's see how you do if you are doing this for real in the laboratory. So finish up your lab activity, and don't forget to study for tomorrow's quiz. And so until then, I'm going to say bye-bye.